There have you never heard of before? Huh?
I guess.
Have we talked about congruent in here yet?
No.
Congruent is an important word. Okay? Let's say we have a segment, A to B, and the length from A to B is 5. Then we have another segment over here. We'll call it C to D. And the length from C to D, the length of that segment is also 5. Can anybody guess why this is wrong? In a way, does it almost seem like it should be right? Everybody don't write for a second and follow with me right here. Why is it wrong to say this right here? Laura, put your phone up. Okay. Well, I guess kind of. He's kind of on the right track there. He said it's kind of different letters. When you say things are equal, you're saying they're exact same thing, aren't you?
Yes.
Insane. Are these two the exact same thing? AB is a different segment than CD, isn't it? So we can't say they're equal. What are they? They're the same. How would you describe how they are the same?
Same length.
The same length, the same size, things like that. So what we do in geometry is we say that AB, segment AB, and then we put a sign like this. That's correct. What do you think that sign means? It means congruent. Congruent means that two things are the same shape and size. Now, you say, well, they don't look like the same shape, they're not angled the same way. Lines don't have a shape, okay? But they're the same size, so that works for, or segments don't have a shape, so that works for that. We'll talk about shape when we get to like rectangles, things like that, when we say this rectangle is congruent to this rectangle or something like that. Then shape will come into play. Now, what is right, it is correct to say this. Does anybody know why? Do you remember why? No, when I don't put a line above this, I'm talking, when I say AB, I'm saying the distance, and I thought we've talked about this, from A to B. And same thing here.
And that is correct.
Because what's the distance from A to B?
It's like 5.
What's the distance from C to D? Is 5 the exact same thing as 5? Absolutely. So that's why that's a correct statement. You know, everyone needs to remember that notes are half your semester test, so they are required to be taken. So please take notes. They were turned in at the end of the semester. If you look on page 63, you don't need to write these down, but they say just basically that congruency in essence has some of the same properties that equalities do. Congruent segments is reflective. In other words, a segment is always going to be congruent to itself. That makes sense, doesn't it? They're going to be the same size, right? Shape and size. Congruence of segment is symmetric. If this segment's congruent to that segment, you can flip the order and you're still saying the same thing, right? And it's transitive. If AB is congruent to this segment and this other, that segment's congruent to another one, then the two first ones have to be congruent to each other. First and the last one. Okay? That's the same thing as the transitive property we did in the last section. I'm not going to go into those a bunch because it's there's not a whole lot to it. The next thing we're going to talk about is what is called a midpoint. Everybody get that written down who didn't, and then we'll talk about a midpoint. Okay? Just want to remind everybody, it's real easy to, we all have bad days, and you don't feel like writing notes down that day, and you know, I guess that's going to happen some. I can't make you do it, but don't make it every day. And if you aren't writing them down that day, you need to be listening. Then you go home, watch the video at home on the internet, and write them down then. But you are responsible for every day of notes, whether you're here or whether you're not. I suggest, of course, doing it every day, and on those bad days, just finding a way through it. What do you think a midpoint is?
The middle of a,
It sounds like the middle, right?
yes.
A point that's in the middle. I made a simple statement here. C is the midpoint of A, B. What am I saying? That C's what?
It's in the middle.
Exactly in the middle. What do you think you can then say maybe happens? What does it mean to be in the middle? To be exactly in the middle. Whether I drew it in the middle or not, whether it looks like I did a good job of guessing where the middle was, and then obviously it doesn't, but close enough. This statement is more important than the picture. I told you guys that C is the midpoint of AB. What does that tell you? That it's exactly in the middle. What does it mean to be in the middle?
Between,
In the center, exactly in between. If you were, let's say you were driving to Tulsa, and you're exactly in the midpoint between Owasso and Tulsa. How far are you from home? The same amount that you are from what? You're exactly in the middle, right? That concept still rings true here. How far is C from B? We don't really know, but what do we do know? That it's what? The same distance from C to what? As it is from C to what? So what do you think I can say about these two segments?
they're the same.
What word did we just learn about? What could I say? That segment what? AC is what? Congruent to segment what? CB or BC? Does that make sense? That's what basically tells you about being in the midpoint. Now, you're going to see this on pictures. Everybody look up here. You're going to see a mark like this sometimes and a mark like this. You know what that means? They are marking on the picture and saying, hey, this is congruent to that. The things that have one mark. It's kind of, a lot of times it's easier to see things in a picture than it is in a sentence or congruency statement. So you'll see that. Okay? Any questions on that? All right, I want to do one example here that I'm going to make up that I want you to write down. Very important example. So we're dealing with the same picture. Get this thing straight. There we go, that's a little better. How in the world are we going to do this problem? When you look at what I said CB and AC were, what class does it remind you of? Algebra. What was the number one thing you did in algebra? You created what? Or you solved what? Equations, right? You guys remember doing that? You sure better learn how to do that in algebra, huh? Anytime you see a geometry problem that tends to look like a what? Algebra problem, 99% of the time, you need to use the information given to create a valid equation. In geometry, that's the case. Now, my question to you, what makes something an equation? Two things are what? Equal. It has a what? Equal sign. So when you're trying to create a valid equation, you're trying to find some things that are what? Equal, or things that add together to equal this, or something to that effect. So we've got to look at the information given. Jessica, sit up, hon. One thing you've got to understand is that it's okay to look at this problem and go, I don't know what in the world I'm going to do there. Really, you shouldn't be able to just look at this and right now, by reading this, the equation just pop into your head. You've got to look at the situation, label some pictures, see what the question's telling you. First of all, the question said C is the midpoint. So they said C is the midpoint. We're talking about this. So what does that tell you? That that's congruent to that. Would everyone agree with that? Okay. That's our first bit of information. Next thing they say A to C. Now when I don't put anything above it, I'm talking about what? The distance from A to C is what? Even though, does that not just represent a number? Stop writing. Let's everybody pay attention right now. Does that not just represent a number? Yes. So I'm saying AC is a number. So I can come up here to my picture and say A to C is 5x plus 4. Agreed? That's the distance from there to there. Everyone agree? What else does it tell me? Distance from C to B is what? That just represents a number too. You would have no problem if I said this was 10 and this was 10, would you? You'd understand what they were talking about, right? I just put an unknown number in it. It's just uglier. So, I have things that look like algebra. I need to use this information and create equations. Do you guys know anything here that's equal? Yeah. What? Isn't the distance from A to C equal to the distance from C to B? Would you guys agree with that? Well, what is the distance from C to B? A to C? 5 times whatever x is plus 4. That has to be equal to, what is the distance from C to B? 7 times whatever x is minus what? I mean, isn't that what the picture says here? Those two are what? You kind of have written the equation right here, haven't you? Now, people get in the habit of saying, okay, it's algebra problem. The two things that gave you are equal. That's not always going to be the case. There's going to be different situations. This plus this might equal something. But anyhow, why did I want to create an equation? Because then I can find and solve for what? So let's do that. How am I going to solve this equation I've made? I need, you want to subtract 5x from both sides? Okay. The reason we did that is because it makes it 0 on the left side, leaving what? Over here on the left side of the equation, just a 4. That's equal to, well, these two are like terms. What does that become? 2x, and then what? What's my next thing to do? Add 8 to both sides. That makes that 0, so I've got 12 is equal to 2x. Does it matter that the 2x is on the right? No. What am I going to do now? I'm going to divide both sides by 2. Why? I don't want to know what 2x's are equal to. I want to know what one of these x's are equal to. So anything divided by itself is what? 1. In order for me to do that, just like up here, I have to keep the equation balanced. If I divide everything on the right side by 2, I got to divide what? Everything on the left side by 2. What is 12 divided by 2? I have now manipulated that equation to find out what x is. So I have found the first part of this problem, have I not? Second part of this problem. Everybody listen. They ask me to find what AB is. That's the distance from A to B. That's the whole thing, isn't it? Well, I probably need to, whatever AC is plus whatever CB is, that's going to be AB, isn't it? How am I going to find what they are? Well, I'm going to put what? What did I find? I found that X was 6. A to C was what? 5 times whatever what? X is plus 4. What did X end up being? 6. So what is this? 5 times 6 is what?
40.
So the answer is what? AC is 34. If we did this correctly, what should CB be? So what is the distance from A to B? Now why is CB the same as AC? Because they're congruent. Now, I can check myself, put 6 in there. 6 times 7 is what? 42 minus 8, 34. So that's right, isn't it? Make sure you've got this example down. I'll freeze it for a second. And then we'll go to the worksheet. There wasn't one like this on the worksheet, that's why we did this one. Guys, you're going to do equations or problems like this all the time in geometry. There'll probably be 2 or 3 on each homework assignment you do just about from this point on, not always. Let's put it this way, if you don't do the 2 to 3 or even just sometimes one hard one like this, and you skip it and do all the rest of the others, good chance I'm going to take a lot off for not doing just that one. Maybe 2 to 3 points, who knows. I want you to try the hard ones. They help expand your knowledge of the material. Again, write the problems, draw the figures, show all steps and work. Prove to me you're doing the work. Just like I told you on those ones that's the absolute value, I know you know what 6 minus 4 is. Just show me by writing 6 minus 4 when that's all there is to it, that you understand the concept of what we were doing, finding the distance between 2 points on a number line. I know you can count the distances, but I wanted to see if you could do it if the numbers were bigger. Everybody got that? Okay to go on? Okay, got a couple still going. All right. Use the number line to determine whether each statement is true or false. W is the midpoint of Q to R. Well, how am I going to find the midpoint between two things? This is something we haven't discussed that we need to. To find the midpoint, I'm going to add, let's say A plus B and divide by 2. I'm going to add the coordinates together and divide by 2. So, the midpoint of QR, well, the coordinates of Q is what? 1 plus, what's the coordinates of R? 5. And then divide by 2. 6 divided by 2, the midpoint is what? So, is W on the midpoint? So that's what? False. And we did explain our reasoning right here, didn't we? By saying the midpoint should have been what?
3.
S is the midpoint of TV. We can explain our reasoning by saying -6 because that's what? Where T is, correct? Plus, what are the coordinates of V? Huh? I can't hear you. -2. And I need to divide that by 2. What is -6 plus -2? -8. That's when you multiply. Divided by 2. So where should the midpoint be? Negative what? -4. Is S at -4? Look where S is. Is it at -4?
Yes.
So what is this?
True.
Is SV congruent to TS? How big is SV? Distance from S to V is what? 2. What's the distance from T to S? So are those two congruent? Is SV congruent to TS? Is SV congruent to TS? Yes. So this is true. V is the midpoint of TW. 1, 2, 3, 4. 1, 2, 3, 4. True. W is the midpoint of VR. 1, 2, 3, 4. 1, 2, 3. It is not, so that's false. And how am I going to justify it? I'm going to justify it by saying where the midpoint should be. -2 plus what? 5 divided by 2 would be would be what? 3/2. The midpoint should be at what? 1.5. Do I need to do any more of these, or are these okay? Can you guys do those? Is XY congruent to YX? True. Do you know why? If AB is congruent to BC and BC is congruent to XY, then AC is congruent to XY. Is this true or false? We're basically saying these two are the same size, right? And then one of these is the same size as something else over here. Wouldn't this have to be the same size as that? That's true. Huh? Oh, it's false. Why is it false?
It has to be AB, not AC.
What they write down here. They tried to trick us, didn't they? They wrote AC, right? So guess what? It's false. And you could say AB is congruent to XY. BX is half the length of BY. Then B is the midpoint of BY. True or false? Can you think of an example where it wouldn't work? How about this? Let's say the distance from B to Y was 10. Then the distance from B to X was 5. X wouldn't be the midpoint, would it? think I'm doing it right. But B sure wouldn't be the midpoint anyway. Plus it could be on a different line. A line has only one bisector. That's false. Because the line goes on forever and ever, so it's a terrible, terrible problem. To bisect the segment, we don't not doing construction, so don't worry about that one. Okay? And plus, a bisector of a segment has infinite, because you can draw a bunch of lines through it. But I guess a bisector could be a point, but